Hey there, and welcome. Today we are diving into a huge challenge that so many data science teams run into. How do you actually manage all the knowledge that gets created in these really complex, always changing projects? We're going to look at how you can go from a process that feels like a black box to one where every single decision is totally traceable.
So I want you to think about a project you've been on. If you looked at it 6 months from now, could you explain exactly why you engineered a certain feature a specific way, or why you picked one model over another? If the answer is a bit of a, maybe not, then you are definitely not alone. So many projects turn into these black boxes where the why behind critical decisions just gets lost to time.
And here's the fundamental reason this happens. Data science just isn't a straight line. It's really a journey of discovery. Your understanding literally evolves as you get your hands on more data, as you run more experiments. What seems like a brilliant idea in week 1 might be completely useless by week 10. And it's this constant evolution that makes capturing knowledge so incredibly hard.
So let's really dig into this challenge of lost knowledge and see what kind of problems it actually creates in the real world.
Now, what's wild is how all of these points are so deeply connected. I mean, think about it. When those key insights get lost, the reasons for your decisions just fade away with them. And that makes trying to reproduce your old results a total nightmare. And don't even get me started on trying to bring a new team member up to speed. They've got no map to follow. It becomes this vicious cycle where valuable knowledge just evaporates and teams are forced to rediscover things they already figured out months ago. But what if there was a way to bring some real order to all this chaos? Let's take a look at a structured approach to fix this. A system really built for sanity, and it's all based on a knowledge graph.
Okay, so here's the key idea. A knowledge graph isn't just another database. It's a connected web of information. It actually links the why of the business problem, that's the domain knowledge, directly to the how of the technical solution, the data science models. It creates a single, coherent story for your entire project.
And this is where the rubber really meets the road. All of a sudden, you can actually trace how a tweak in your model directly impacts a key business metric. Your business analysts and your data scientists are finally speaking the same language because they're using a shared context. This doesn't just make development easier, it creates that one single source of truth that every team dreams of. All right, that all sounds fantastic in theory, but how does it actually work in practice? Let's dive into what's called the observation pipeline to see how we can capture all this knowledge in a really structured way. The whole process is broken down into these 3 core stages that you'd find in pretty much any data science workflow. And at each one of these stages, we're going to systematically record our findings as observations. It's all about making documentation a natural part of the discovery process, not some chore you have to do at the end. First up, exploration. This is ground zero. It's when an analyst looks at the raw data for the very first time, and they're making these crucial observations. Is this data super noisy? Are there some bizarre outliers in here? Is this even the right data for the problem we're trying to solve? Documenting these first impressions is the very first layer of our knowledge base. Next up is data representation. And honestly, this is where so much of the real art of data science happens. Raw data is almost never ready for a model. You have to transform it, create features, make assumptions. Capturing the why behind these transformations, like why you decided to normalize one feature but not another, is absolutely critical if you ever want to reproduce your work. And finally, we get to the modeling observations. This is where we write down why we chose a particular algorithm, let's say XGBoost over a simple linear model, and the specific parameters we used. And this isn't just about logging hyperparameters. It's about explaining the whole thought process that led you to those choices in the first place. Okay, so we're making all these different observations, but how do we structure them? What's the glue that holds this whole knowledge graph together? Well, that brings us to the most foundational piece of this whole system, the ontology. This quote just nails it, doesn't it? Every single project has its own unique language, its own set of concepts. An ontology gives you the formal structure, kind of like the grammar, for defining that language and connecting all the different pieces of your project's story. So in this system, the ontology isn't some abstract academic concept. It's a practical, hands-on tool. It's what defines terms like exploratory observation or modeling experiment. Think of it as the blueprint that makes sure every piece of information is stored in a consistent, predictable, and, most importantly, connected way. It's the shared vocabulary for the whole team. And using it is just this simple, repeatable cycle.
At each stage of your project, you just load the existing knowledge graph, you add your new observations, and you save it. The knowledge base grows organically and logically right alongside your actual project work. It's that simple.
Now, we all know that not all data science work is created equal, right? Sometimes you're exploring brand new ideas, and other times you're just applying a method that's already proven to work. Let's see how this system can support both of those workflows.
This slide lays it out perfectly. On one side, you've got the application pipeline. Think of this as your production mode, your workhorse. You have a model that's established, and you're just running it on new data. But on the other side, you have the experimental pipeline. This is the R&D lab, the playground. This is where you're trying out all sorts of different models and data representations to find the absolute best approach.
And here's the real magic. These two things aren't separate at all. They're deeply connected. The knowledge you gain and, critically, document in your experimental pipelines is what directly informs and justifies the design of your robust, production-ready application pipelines. Your R&D phase now has a direct, traceable link to the final product. So, to kind of wrap up the how-to part, here are the golden rules. If you change the data, log it. If you choose a model, explain why. Be super clear about how you're measuring success. And maybe most importantly, log every single assumption you make along the way. That right there is the recipe for a project that's truly transparent and reproducible.
So let me just leave you with this thought. Imagine a world where every single data-driven decision in your company, from that very first look at the data all the way to the final model running in production, was fully documented, completely justified, and totally traceable. What would that unlock for your team and for your business?